Okay, thank you very much. A little introduction about myself. Sorry, I think you've seen me already anyway in the other sessions over there. So, but I want to tell you about my work. I work at a consultancy called Königsweg. We are working in Germany when we are working on digital transformation, data science consulting. I myself consult on data science or train people on data science or Python. So I'm quite active in the community. Apart from this conference, I'm also involved in EuroSciPy and the German Python conference. And I really like working with speakers, reading all these submissions because it's awesome stuff in there. So I like to talk as well and train. There's a little bit the scope we cover as a company, but I want to a little bit tell you about my story here in deep learning, because I've been doing some experiments in deep learning here. And this is actually where the inspiration comes from. So if you expect this is like a talk to explain how does deep learning works because you can make shitloads of money from that, you're wrong here. It's more like what you can do in experiments and what works and probably doesn't. So this is where my inspiration comes from. I visited PyData London last year, and there was Gene Kogan. Gene Kogan is an artist, and he uses AI for art. And he gave a keynote there. Down there, there's a link for the YouTube video. It's totally worth watching. And I said, hey, wow, awesome. Because probably some of you know, my first career was not in IT. It was in the music industry. Not as an artist, but I was a label manager, and I was creating a lot of like techno house records at the time in the 90s. And since we ran an administration problem, I was forced to learn or teach myself programming, and this is how I ended up here. So I said, okay, wow, great. So you can understand, I'm constantly drawn to creative stuff as well. So I thought, okay, wow, great. I always want to do it, but you see a keynote, oh yeah, let's do it, but then you get back to work and have stuff to do and you forget. But lucky me, I had a project which was work-related, and it involved improving the resolution of images, because we had some old images which had like the resolution was not good enough for current use, because it was like images recreated for digital media 10 years ago, and also the whole thing changed. So it was like, so I used this library actually for neural enhanced. Neural enhanced trains on a data set, trains a network, and then you can basically do a better job than Photoshop in improving images here. This is just like a simple example I've taken from the Git here. So I said, okay, well, that worked well. So that was my first step into getting it to work. So I said, well, okay, the prototyping went well. So I said, okay, now it's time to get a eGPU, something I wanted to get all the time anyway, because you can plug now an external GPU graphic card into a MacBook like this, use Thunderbolt 3, it's a super fast connection, and thought, hey, well, that's very good for making better prototypes and something you can release later in the cloud for production. So, so I got this. This is basically my experiment setup I have in my home office, and I'm using this workbook. So actually, cool. So I got this. Some lessons learned here, especially if you're on Mac OS. Apple always says, hello, one more thing, and it's all plug and play, and we have eGPU support. Yeah, but Apple has some eGPU support, but is favoring the other company, not NVIDIA. But for data science and all the AI stuff, NVIDIA and CUDA is way more enhanced and the thing to use for deep learning and the libraries. So actually it was a little bit painful to get the right NVIDIA driver, because they really depend on the OS build version. So it makes a difference whether you have a fresh install of the system or you did just like an update. So there's a great source I want to point to. It's eGPU.io, and really a lot of kudos to Gulake and FR34K. They write some great installers, scripts, and a lot of help to making this work on Mac, because I didn't want to have the whole cloud overhead. So I like to move stuff to the cloud, but I wanted to have things close and not just like an extra layer, which could make some other troubles or something like that. So okay, I got this to work, and I had a weekend all for myself, like a long weekend. I was like, my partner was not at home, so I could spend 24 hours working on nerdy stuff. And this is where my journey started. I started with style transfer because this was something I thought it was really nice. Who has seen style transfer before in the media? Okay, it's only half, because that's something, from my perspective, and this is also something which you will see in this talk a lot. From my perspective, I expect 100% or 99% have heard about style transfer because it was big in the media, but still, there's only 50%, so let's explain a bit. It's basically, style transfer is something you have. This is Tübingen at night. Tübingen is a small town in Germany with very smart people, and they came up with this algorithm. And basically, the idea is you train an image on a Van Gogh or a Picasso, and then you apply this style to a photograph. And basically, you have Tübingen at night painted digitally by somebody like Van Gogh. And this is quite amazing and looks really nice. So I thought, okay, let's experiment. And in the first step, I reproduced some stuff. So I just took the stuff, and I was like, as a kid, I always liked these comics. They're French. Also, they are called in German Valère and Véronique. So we already had, like, in my early childhood, in the 2000s, okay, no, actually in the 80s, we had the main characters was actually two people, and it was a man and a woman, so it's actually quite progressive, not only like one hero. And there's, like, for example, these modern Flash comics, which I, from the style, don't so much like. They're a little bit soft. So I really like these old French style comics. So I wondered, can I make the Flash comics look like Valère and Véronique? So how does this work? How does this work? This works. Okay. This is a page from an old Valérien Véronique, or it's called Valérien in French comic. We take a part of the image and apply it on this other image from a modern Marvel comic. And this was my very first style transfer ever, and I just said, oh my God, this is awesome. I mean, it's awesome, and it's also so easy. I just took some code from GitHub, used deep learning, and hey, I should drop everything else and just do deep learning in the future. We also happened to be on holiday in Scotland last year, so I had also these amazing Scotland pictures I could transfer in a Valère comic or like the Flash style. There's some pictures I had taken while traveling in museums, like the tiger afraid of the rain in the jungle here. And it's, oh wow, and it all worked really well. And then, of course, I tried other styles. For example, I took a more like psychedelic sequence from the Valère and Véronique, and this worked pretty well either. So wow, this was a really nice thing. And another thing, you can even transfer the style on a whole page. So this is a full page of one of the modern ones, and now I make it look like one of the style I favor. Another nice finding on the way, and this is one of the key messages as well, AI, and this is also another thing which probably draws me to AI and deep learning, is a lot about experiments. So it's not, there's like not recipes, and there's some good practices maybe, but still you have to experiment. And another thing, you have to think as well about stuff. So, for example, one finding on the way while doing the experiments was I thought, what if I take an old Flash comic, like one from the 50s? And I only was able to get hold of like a really bad image of that. So basically, compared to the picture on the right side, the original size was like this. It's like really tiny, super blurry, and with style transfer, I could just make like basically brand new. And this is like still not an optimized style. This is just like try and do stuff. So actually, this is like really good finding on the way was you can use this for improving images, and probably the use case would be if you have old books or like, probably like these thermal printed receipts from somewhere nobody can read anymore, to improve the resolution here. Another nice thing, and it also like brings me to, okay, where does art start? Where does it end? What do you get if you train on something else and just put white noise in there? And I just sent this picture, hey guys, to some friends. Hey guys, I'm at Tate Modern. I really favor this picture. What do you think? And they said, oh yeah, it's a great picture. And I said, no, my computer made that. And of course, we're at EuroPython, and we want to do spontaneous stuff. So last night I thought, what about doing a EuroPython comic? So let me tell you about Stan Prokop. I found all the images on Twitter. So this is Stan. He tweeted, Stan is his first EuroPython, so he was like super excited. So, and he tweeted this picture, and Stan, it's basically a little bit made up story, Stan enters EuroPython. So he meets some friendly Pythonistas on the way. The master of ceremony, Marc-André, enters the stage to greet everyone and says, hello, welcome EuroPython, and tells you about all these great keynotes and stuff. And then another magician enters the stage, Dave Beasley, and tells you about die threads. Yes, it's German, die threads. And yeah, you see all the stuff, and it's really easy to do something like this and make a nice comic, or make it, maybe this is something I felt, so maybe this is more like some picture suitable for something more psychedelic, because it's like Blade Runner-y. You can also like do another comic in a different style, like this, for example, the async.io stuff, and all the stuff. Most of the work was collecting the images from Twitter. Or you can have like a picture like this. Or if you ever wondered about quantum computing, you can have like this. Or you can also like have the cheese shop as a comic. Okay. That was the EuroPython special part. Okay. Now where do I stand? I said, hey, well, this works really great. Awesome, deep learning. So what do we have? Where do we stand here? Because a lot of this talk is also about the process and having like a proper process when working with stuff like that. So I got my local eGPU lab. I got the ability to scale in the in the cloud. Not only David Beasley scales to the crowd with linting, but I scale to the cloud. Reproducibility documentation of the experiments, that's like still like baby steps. And this is also something, learning on the way, which was really important, because we have parameters. We feed a lot of parameters like learning rate, random seed number, which pictures do we actually use, input, output. And to these experiments, you have to be able to reproduce them. So you also have to document them properly. So I wrote myself like a little setup script to say, okay, this is the picture I'm working on, these are the parameters we're using, and all the stuff. We probably could also use cookie cutter, but at the time, I did not think about it. And of course, there was the big question, which framework do I use? Because there's TensorFlow, there's stuff like Keras, or there's PyTorch. And so basically, when looking at what do I sell for, I decided to use PyTorch. It's because it's research friendly. It's, I think, very accessible for a Pythonista. So I also know TensorFlow and stuff. So I thought, yeah, well, it's a little bit weird. So, but PyTorch, you basically look at the code and know, okay, I can work with this, and it also has a great community, responsive community, and it's backed by Facebook, which was probably, yeah. Let's see, this is a neutral thing. It's backed by Facebook research. They're the good guys in New York. Okay, the lessons learned were here as well, because I want to use my GPU, and PyTorch has to be compiled to work on this machine. And this was actually unexpectedly quite painful. It was not conda install or pip install anything. With the GPU, I had to compile it, and it turned out PyTorch does not have something like a master and a dev. They always commit to the new stuff to the master, and it's a super complex project. So turns out some other dependencies they use broke the compiler at a quite late stage, which was painful because stuff like that can take like half an hour. Actually, I finally made it. So I checked all the branches of the commits and found one that works, and then I used Condor for keeping a master copy of a working version. So if you don't know, if you have something compiled, Condor is really good at cloning your environments. I wanted to keep that copy because it's been maybe I wasted one day on that unexpectedly. Okay, then part two, like the vision. So you can imagine I feel like this. Like, oh yes, style transfer, everything. I touch deep learning, it works, it's magic. So I feel like this, and I got like quite excited and said, okay, let's propose a talk for PyData Berlin. It's like a very prestigious PyData conference. I said, hey, wow, deep learning can basically solve everything. Why not even do something really fancy and try to synthesize this. And who knows this? 1, 2, 3. Okay, 20% are German. Yeah, it's one thing I'll explain. So this is like what, 3 question marks and 3 colors. What is this? Actually, it's called Die 3 Fragezeichen. It's actually an American juvenile detective stories book series. It's called The 3 Investigators. It's basically they investigate mysteries. They're like young teenager detectives. They're located in California. It's pretty old. So it was very popular, but it's super popular in Germany. Turns out only in Germany because it's, I don't know, like, and that's the other thing I'm going to explain in a bit. It's called Hörspiele in Germany, which is something like radio dramas, which is like, then there's 200 taped radio dramas. So I know for deep learning, I need content. I need a lot of content to learn from. So I thought, okay, will like 200 radio dramas be enough to get something working with deep learning? So, okay, so what's a Hörspiel? Actually, probably you have heard of Orson Welles' War of the Worlds, not the movie, the radio thing. Okay, there's definitely some education to do here. Because this was awesome. I mean, here you see there was like in America, like when there was just like the age of radio. I mean, we are pre-internet, we even like pre-television now. And there was this guy, Orson Welles. He also did the best movie of all time, Citizen Kane, which is absolutely worth watching. And he is like, I think he's in the mid-20s, and there were like these people, like actors in studios, and they were like speaking, and there was like a narrator, and the people made sound. So basically, it was a movie without pictures at that time, transmitted by radio waves all over the country. And the thing which Orson Welles, as the genius Orson Welles did when he was like in his mid-20s, he made it like a live documentary about aliens invading the US. So, and that's also like where the old Tom Cruise and stuff movies come from. And people were really panicking because at that time, in the 1920s, nobody was aware you have something, news or stuff on the radio is not real. It's not news. It's not like, and people really panicked. So this is like a super classic. So a Hörspiel, now which is still popular in Germany and for kids, but also for adults, or so like you can have also like Harry Potter as it has. It includes voice recordings, noises, stuff around. So basically, I think a movie without picture basically brings it to the point. So, and it looks basically like this. This is one of the cassettes I used to have as a kid, the Drei Fragezeichen and the Whispering Mummy. It's like super. This is like just like how like a transcript looks like. There's somebody speaking and help, 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 help me. Yo, there's some parrot speaking stuff. This is like something, and it sounds like a little bit like this.
Hier, Kollegen, lest selber. Ihr würdet es mir nicht glauben, wenn ich es euch vorlese. Ihr würdet, glaube ich, spinnen.
Wie kann eine 3000 Jahre alte Mumie flüstern?
Er ist der Ahner des Hauses Hemmel. Vor 3000 Jahren kamen Könige aus Libyen nach Ägypten, um das Land zu regieren.
Auf der Mumie ruht ein Fluch.
Okay, the mummy is cursed. This is like the pictures look, like the covers looks like. It's like the CD covers look like. And so actually there's like multiple dimensions here you can try to will try to synthesize with AI. There's a story and plot, what's actually happening. Can I make up a story? Dialogues? Human speech, scene, and dialogues are like very dynamic, actually. A cover, can I generate a cover for the next radio drama or the radio drama I produce, maybe? And spoken word, can I basically create spoken word and speech sounding like a character? And so let's continue our journey and see how overexcitement can also like, there's some bumpers on the way. So how can I realize this? So I have the transcripts. Luckily, I found the transcripts on the fan site. So I had human transcribed text, which was really nice. I had the recordings because I'm a fan. So I had basically everything at hand. And now let's get the stuff together. So technology sucked a local GPU. So if I had something to working, I could scale it to the Google Cloud, because sometimes deep learning stuff, it takes time. So the workload I sent it to the cloud, mostly the most recent PyTorch version, Jupyter Lab, and of course a recent Python version. And the process for each of the different parts I'm trying to synthesize now is always the same. It's data acquisition, data cleansing, get something, a research paper or something, some work from the internet first, try to reproduce what is presented there, and then verify it's working, and then adapt the solution for my use case. So it's always like simple, like take something, make something to work, and always exchange one variable at a time and not try to change too many parameters at a time, because this is very confusing and you won't be able to know why did this happen or why doesn't it happen anymore. So yeah, and then try to maximize the quality once everything goes into the right direction. So the first mission, fabricate text to be spoken by a character. But I mean, remember, style transfer and the whole picture thingy worked really well. So I said, okay, that's easy. Yeah, so it's also like there's 296 characters there. Just like a little impression about the text corpus. It's all in German language, 1.5 million words, and 56,000 of them are unique. One little tip on the side, probably in the wrong room for that, but PyCharm is actually quite great combined with Selenium to scrape scuff, because I had to scrape scuff here, and I used the debugger from PyCharm and Selenium. So Selenium is a remote, you can test browsers or browser software with Selenium. So basically, I can automate my browser, combine it with the PyCharm debugger, with all the halt points. I see what's happening, I can see where I'm with the source code, and basically, it's very easy and fast to scrape stuff from the internet here. So if you use Beautiful Soap, which is also great, I used it in the past as well, and still are digging through HTML code, have a look here, because this is like super effective, because you actually see and can interact with what you're doing. Who has heard about Andrew Carpathy? Okay. Who has read his blog post about RNNs? Okay. 3, 4 people, okay. Because in the internet there's a lot of stuff like this. And this is something really good. Andrew Carpathy was still a PhD when he wrote this blog post. He's not a chief data scientist of Tesla. And he wrote a great blog post about recurrent neural networks. So, and basically the outcome here, he explained how it's a quite long blog post who explains really well how everything works with RNNs and what you can do. And basically one of the findings or results is, okay, feed it a lot of Shakespeare, and you can basically generate new Shakespeare with using RNNs. So, awesome. So if somebody can demonstrate in the blog post to generate somebody like Shakespeare, I mean, like, it's not just like any, it's like Shakespeare. I can do my Child's Play, so I mean, I can do these characters, I can do this as well. So let's get this going. So first, I got something from the internet, produced something which looked Shakespeare-y to me, because one thing you always also have to consider, you can show me a lot of stuff in English and can claim, oh yeah, this is medieval English, or say, yeah, this is some accent or like a local dialect. I cannot judge, I'm not a native speaker. But yeah, looked good to me, and this is what I produced. This was something produced by a character-based RNN, so basically you feed all the characters and the distances from the characters into a neural network, and it remembers like how likely every other character in connection with the others, and this is like one of the results from my text corpus. And of course, why are the Germans not laughing? Okay, thank you. But I also asked Google to translate it for English. So this is like the English translation. Actually, it's quite accurate. It's a very good representation of what you see here in German. So it really looks in a way like German, and there are some real German works in it, but Schlockolianer is a great word, but it doesn't exist. Yeah. So, and also the grammar is like, well, the grammar, we could really work on the grammar. So actually this makes no sense at all. And so I thought, okay, well, maybe let's do something word-based, because why did I approach character-based first? Because characters, I have to represent everything as a number when I feed. the RNNs. Of course, if I have a text corpus, I can easily like only work with like 40 characters. But if I need to assign a unique number for each and every word, I suddenly have like 50,000 to deal a lot with 50,000. And these things and these matrices we work with, they really blew up. Like, I mean, it takes a lot more space and computational power, and we probably also like break the RAM of my CPU, GPU, because GPUs don't say, okay, I'll do this later. I mean, if you put too much stuff into your GPU RAM, it will just crash and you start from scratch. It's not really, it's not as easy to manage like a CPU on your computer. So let's do something. Yeah, on another finding, you can also like send it to your friends. Like, well, this is also like, that's not too bad, German. Yeah, and then people ask, are you speaking Wong? And Wong is like a youth language in Germany, which is like really bad German, like from teenagers who are too lazy to work with. So actually, we could also say, yeah, this is like real. AI caramba, yeah, as Vincent probably would say. This is a picture taken here in Edinburgh and style transferred as well. It was the PyData meetup in Edinburgh, and Vincent did a great talk about something related. He was talking on also deep learning and AI, and thinking is really important about when you do stuff. So let's settle, maybe it's just like the character thing. Let's do the word-based thing. And I also like below the courtesy, the Google translation, so, which is also quite accurate, although I don't know why Google decided to write Callan in uppercase or title case, because Callan actually above is a verb, but I don't know. It's just to give you like some impression if you're not a native German speaker. So native German speakers tend to find this like really funny. So I said, well, didn't go as well as I expected. So another of my ideas, and this is the fun stuff again, it's about dialogues. What about chatbots? But I didn't have time to build chatbots now as well, so I was doing some research and I stumbled across this. There's like the Captain Picard, like a Star Trek Next Generation chatbot, and there's also like a paper on ArchiveX about it, and you can probably found some blog posts about it, and you also said, oh yeah, somebody took all the text from Star Trek Next Generation, and Star Trek Next Generation is over. So basically, they build a chatbot, and you can, while waiting for probably they will come up with 11th season or whatever, you can just like Twitter and you get a chatbot. Okay, awesome. And we read this stuff, and we of course believe all this stuff. So I said, okay, let's try this. And I just tweeted to them, I'm Locutus. Actually, I tweeted something from the original text corpus there to make it easier to minimize anything special. And it was basically just like, yo, boo, 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 and it was really hard to get this. Yeah, it took like a week. I always got these tweet messages, somebody, Wolf replied or whatever, but it was not really useless. So it was always like a great idea, totally blown up by some blog post, but not really working, although still thanks somebody does stuff like this on Twitter. Like, I don't want to say they're doing a bad thing, but maybe sometimes people pick up stuff from other people and think they need to exaggerate anything with AI currently, which is really bad because people in management or deciders, they tend to believe this. They read only like the executive summary and said, oh yeah, somebody did Star Trek. Yeah, right. Obviously not. At least not from the quality I expect. And I watched all of them. Okay. Speech, how can I now fabricate spoken language and make it sound like one of the characters? So there's something really new. It's called Tacoton 2. It's the open source implementation of the most recent Google Deep Voice they presented for the assistant. I had a nice natural speech data set. So basically, you always have a piece of audio and a text. It's all spoken 24 hours, one female speaker, and I tried this, and it uses MEL spectrogram, something I haven't stumbled across before. A MEL spectrogram is basically a representation of the frequency when I do like a by or say a word. Basically, we create a spectrogram. It's not just like, so it's more like a really nice representation. And it learns actually from the spectrograms here. Okay, let's do this. So I have this trained, and I trained it for like 10 hours, and the data set, somebody speaking something, and I have just the text and no additional meta information. After 10 hours, it sounded like this. So it's always like saying the sentence above. So after 10 hours, okay, I can't understand anything, but there's some certain rhythm. So let's see after 14 hours. 14 hours, it sounded like this. Whoa. It's alive. Okay, something's going on here, something's coming to life, and after like 5 days of training.
Once upon a time, there was a little mermaid named Siren who lived with her stepmother under the sea. He didn't get to go out to sea like any other.
And remember, this is a model I own. It's like 330 megabytes, and I can feed any text into it and read it. It's of course not the quality we see with Siri or Alexa when they speak something, but this is just like, this was really simple to do. So actually, this was quite impressive.
Once upon a time, there was a little mermaid named Siren who lived with her stepmother under the sea. She didn't get to go out to sea like any other.
So after 9 days, this was pretty awesome. Still, there's a lot of room to improve. I wouldn't really sell this to a customer, send it to production, say, call Apple, forget about Siri, I have Siren. But actually, this worked really well. And of course, so I said, okay, proof. For me, the proof was I did this in English language. So let's do this in German. And the lessons learned was, it's almost impossible to find a comparable data set in German. I found some data set in German, but it was not really useful because it was not properly cut. So actually, I'm really missing data to do a proof of concept here, unfortunately. And of course, that's another thing. Although German, I think probably 100 million people in Europe speak German as mother language. It's a big market, so we have everything, like we have dubbed television, we have dubbed everything in German, but turns out the majority of the papers, the research, the data sources is all in English. Well, also one reason is in German things work differently, and it's also like a call to action to change this, because yeah, I'm limited, so I'm just working on how can I synthesize, how can I create my own data set and scrape radio, and maybe I talked to the Zeit, which is a newspaper, they gave me API access, so maybe I can generate some data set to learn from myself, because I don't have resources to cut audio or to like read all this myself. So, well, let's see. I'll keep you updated, keep you posted. And of course, for the style transfer, there was another task, and it's just I'm finding because people speak. You remember when I played the radio drama, somebody speaks, somebody else replies, and I need to basically cut it by person if I want to extract how the sound, how somebody speak, if I want to learn and transform this on some other audio. So I said, well, great, I have the fan transcripts. I only have to use Google for a transfer script to get these end and start times, because I have the audio, and with the end and start times, I can automate cutting the audio. So if there's only Justus Jonas speaking, one of the main characters, or Bob Andrews speaking, one of the main characters. And actually, that worked in a way. Actually, my finding was I expected, because it's a recorded audio, there's sometimes little noise, but most of the stuff is clear language. And basically what Google basically sent me as transcription was sometimes the quality was way worse than I expected. I expected something very good, and it was like, well, it was okay in average, and it also like contained many bad words, and actually it felt like, okay, these are like, of course, corpuses, they are trained, thank you, they're trained on chats and stuff, so actually I had some, I cannot say this because it would be COC, but it's like, okay, anyway. Yeah, some really nasty stuff in there as well, which definitely does not belong into a children's Hörspiel. So, okay, it worked in a way, but not enough. So next step is actually to solve the data problem, get the data set. And also the next step, because I don't have any characters to learn from, I only want to point you to the SoundCloud thing here. It's speaking like Kate Winslet, and somebody trained an audiobook from Kate Lindsack and made something else read as it was Kate Winslet. And it's basically, I don't want to play it because we're a little bit running out of time. It's basically comparable to the quality we've seen before with the speech generation. So it's also impressive and not too bad. There's still some potential. We still this is not a fully explored space yet. So, okay. So, plot fabricate detective story. I started my research and found out this goes way back to the 1960s, how to generate stories, even like there were stories generated for some Western TV shows in the US back in the 60s and 70s. I said, okay, don't touch it. I have to do some more research because this is probably more not a deep learning problem because, for example, there's some rituals in these stories I want to use. For example, they need a potential new client. They give them the business card, and the client always replies, oh, what is the three question marks are about? And Justus says, oh, it's about mystery, blah, 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 blah. And this is something, this has always happened, and I don't think an AI will actually pick that up. So last step, the artwork. How can I actually can I at least announce my product on Amazon because I need a cover, a title, and hey, I can fix the rest later. So there's convolutional neural networks. It's basically we know this from style transfer. We've seen many examples here. This is just like how the networks looks like. So basically, you learn style from one image and apply to another image, and it's basically all about distances to white noise and combining them. I don't want to go too deep into the tech, so I created a set of pictures to transfer the style on, just to see how it works and to get an impression. So, and these are some lessons learned and also some general lessons learned on the way. There are limits extracting style from an image to a model. So you cannot really extract anything to any further. So there's some stuff that works really well. For example, this tunnel view picture I've taken in Yosemite in a park in California. This works very well on most of the styles I learned. But there's sometimes a style like this. This is like an artwork from one of the detective stories, one of the original. And I thought, okay, this looks like a decent thing to learn from, but if I apply it to one of the pictures that works well, I get a little filtery thing, but not really a style transfer. So it's not everything is working everywhere. And the thing is, nobody will tell you on the internet because that's all cherry picking. Yeah. So there's also like limits applying a style to an image because this is for example, an image I expected, oh, this should work really well. It's a woman dressed up for Halloween, I guess. And if you apply many styles, this is something like a picture none of the styles ever worked on. Yeah. So, but being a consultant, can I write a blog post about this? What will my customers think? Okay, hey, they're total failure. No, we're not. We actually just like, okay, not everything works. This is the thing. But probably because she's dressed like a skeleton, and we learn from a picture data set, which basically is a sample from the world we see. The network learns from the world we see. This, basically, I used the COCO data set. It's an open data set from Microsoft, which is used for many, many research papers you see at the NIPS conferences and stuff. So it's a really good and explored data set, but it was not able to learn that we can learn something here. Mind the cherry picking, because of course I like to show you stuff like this and see your faces and your smiles. Oh, awesome! Alex is so awesome. He does all these great pictures, but Alex is sometimes not so awesome because like all the tech is not so awesome because probably most people skip showing you like the failures or like the average and it's not so good thingies. And of course in the internet it's about it getting attention, and you don't get attention writing about stuff that doesn't work. And I think it's a big problem. Also, like I saw many pictures, I saw many code released on GitHub, and I'm really thankful for everybody for putting this stuff up. But I saw a lot of repetition. I mean, like you have like style transfer in TensorFlow, then you have style transfer in PyTorch, and if you look at the GitHub descriptions, they all feature the same images. They don't even add one custom image. Basically, it's reproducing work, but I'm not really sure whether there's some improvement involved as well. Or if it's just like, hey, I have this nice AI Git, and probably a recruiter will find me and somebody will hire me for a lot of money. So, okay, these are like the images you've seen before, and now I have a confession to make. 3 of them are already fake. Okay, you didn't see that coming. So, which of them are? Like, because we're a little short on time. these are like the 3 fake images. And I showed it to people who have worked on this before. They were able to spot mainly like 2 of them. I showed them to fans not just like to friends, okay, which are fake, and they did not really see any of them. So these are just like made up. So they're actually like the titles are real, but I exchanged the picture. And yeah, then the code also we find online. It's also, I think, quite nice. So you're Python, and we preach Python 3 for quite some time, but it's really, I was quite shocked. You find there's some super recent thing released by Facebook or like a big company, and it still uses Python 2.7. And it was released just like a few months ago. And if you're not aware, Python 2.7 will retire in a bit more than a year. So the clock is really ticking. It's like, no. So don't use Python 2.7 for anything new, actually. So it's really bad. And another thing I find, for example, like, another thing I found, the code quality. I call it sometimes the benefits, but also like the curse of Jupyter notebooks. Very often you see like functions with closures. What is a closure? Closure is a reference to a variable which is not within the function, so it looks up in the namespace above, which it's working as a script in Jupyter notebooks, but it's really bad if you are new to the code and you want to understand the function, because you have to look at, hey, where is this variable actually doing? What is it storing? And then you have like 1 page up in the Jupyter notebook, and also you cannot really use the function somewhere else or use it to a submodule. So actually, this, like the code quality, of course, it's researchers, and researchers I will be forgiving, and I'm trying to teach researchers to code better all the time. But of course, something where the code could be better. Also, like another nice thing is using built-ins for variable names, like input or equals or list or something like that. And so there's some improvement in code to be done as well. Probably if you're real Python and Pythonister, so you're able to fix it. So what are my future steps? So though not everything was like magic like it felt in the beginning, I really want to continue this project and improve it, and also maybe combine it with other non-AI techniques, something maybe more deterministic, or like a decision tree for generating stories and stuff, or a nice combination of both of it. So these are like my future steps. So like key takeaway here is don't get too crazy about all the stuff we see on Twitter, online, because like it's a lot of hype going on there. Though we cannot say it's just like a stupid hype, because AI is a thing. It's something you can do, something really useful, but I think we have too many false impressions and images in our heads, because like every newspaper always like, oh yeah, it's AI, and we see a robot, or you have these movies with like an AI relationship. And I think this is all pointing ourselves to the wrong direction. It's not always working. And another thing is, if you remember old phones, they were inspired by Star Trek, where you basically have like the Star Trek thing you think, but actually, no, phones look like this. So we have a lot of stuff from media and Hollywood in our heads, and also like in AI and robots and stuff. And we have to really, you should really try to let go and say, hey, this is entertainment and this is something else you can do, because you also have to open your eyes. The experimenting opens new opportunities and possibilities. For example, while just playing around, I find a nice use case for, okay, I can have like bad scans and I can really improve them. Yeah, so I decided to continue this project and continue and give like constant updates if you want to hear about it. 2 really small announcements. So if you happen to be in Frankfurt or southern Germany, there's meetups. We have just launched PyData Frankfurt. We're going to launch in September. And there's PyData Südwest, which is Heidelberg, Karlsruhe, Mannheim, Stuttgart. It's already launched and going. So if you're around in the area, and we would be very happy if you reach out to us to contribute a talk. Or just come by and have a drink or a chat. And Peter's always like happy to show you Karlsruhe and Stuttgart, isn't he? Yeah, it's Peter, one of Südwest organizers. And we also have this great conference coming, PyCon.de in Karlsruhe at the Center for Media and Arts, end of October. So Karlsruhe is down there, but it's very well connected to airports and fast-speed trains. And it's one conference which makes keynote speakers really happy because they are really treated. So first keynote speaker we announced is Wes McKinney, the creator of Pandas. And Wes replied yesterday on Peter's lightning talk, said, ich freue mich sehr darauf, I'm really happy. So thank you very much. And if you have any questions, I'm around the conference, just come talk to me. Thank you very much.